Hello everyone. In this video, we're going to be integrating an interesting function. We have dx divided by x to the 7th power minus x, and we're going to integrate this expression. So I'll be presenting two methods, and one of the methods is called the brutal approach. So let's start with the first one. I'm going to take 1 over x to the 7th power minus x and do partial fractions on it. Obviously, to be able to do partial fractions, first you have to factor the expression. And notice that x to the 7th minus x is a common factor. So we can go ahead and factor out an x. And inside we get x to the power 6 minus 1, which can be written as a difference of two squares or difference of two cubes. Either way is fine, but let me go ahead and use difference of two squares here. That kind of makes it a little easier. With the difference of two squares, this gives us x to the 3rd power minus 1 and x to the 3rd plus 1. Now from here, we can factor this even more because x cubed minus 1 is a difference of two cubes. So we can write it as x minus 1 times x squared plus x plus 1. And x cubed plus 1 can be written as x plus 1 multiplied by x squared minus x plus 1. So we get a gigantic expression from here. And then now we're going to go ahead and split it up, right? By using each of the factors in the denominator. So let's go ahead and see how we can do that. X is a linear factor, so it's going to be like a over x. X minus 1 is also linear, so b over x minus 1. X plus 1 is also linear. So we have three linear factors. Let's go ahead and write them first. And then we're going to deal with the quadratic factors. Since x squared plus x plus 1 is not factorable and it's quadratic, we have to write it in such a way that the numerator is linear because the difference in degrees must be 1. So we can kind of write it as dx plus e divided by x squared plus x plus 1. And finally, for the other one, we have a similar structure, fx plus, not e, of course, f of x, not f of x, fx plus g, okay, divided by x squared minus x plus 1. So this whole thing, when simplified, is going to give us the values of a, b, and c. Obviously, this is going to be super duper tedious, don't you think? One way to make it a little easier is using certain values, like using some symmetry and maybe replacing x with certain values like 0, 1, negative 1, so on and so forth, right? Anyways, to keep a long story short, I'm going to give you the values of those. So a is going to be negative 1 from here, and you can solve for yourself if you want to check the result. B and C are both equal to 1 over 6, and then D is equal to 1/3, E is equal to 1/6, F is equal to negative 1/3, notice the symmetry here, and G is equal to 1/6. All right, now we got all the coefficients. And what we're going to do, we're going to replace the ABCs with these values. So our expression turns into the following. Starting with 1 over x to the 7th minus x. I don't know why I keep writing 1. Okay. This turns into, by the way, a is negative 1. So it's going to start with negative 1 over x plus 1 over 6 times x minus 1. You could also take out the 1 over 6. No big deal. We're going to do that while integrating. Plus 1 over 6 times x plus 1. And then we're going to get the linear pieces because we have to put these together. So it's going to look like this. 1/3 x plus 1 over 6 all over x squared plus x plus 1. And then we get negative 1 over x plus 1 over 6 divided by x squared minus x plus 1. Wow. What an expression, right? Now we're going to go ahead and integrate term by term. Okay? So from here, if you actually integrate this, this is going to be super easy, right? It's going to be negative ln x. Obviously, you can use the absolute value. And then this expression, this one is going to bring more stuff. So let's go ahead and kind of write it down. We're going to get 1 over 6 multiplied by ln absolute value of x minus 1. And then plus 1 over 6 ln x plus 1. That kind of takes care of all these terms, okay? The linear ones. Now, what about the quadratic terms, right? We can kind of write the quadratic terms this way. we have 1/3 x plus 1 over 6. So 1 over 3x plus 1 over 6. Notice that we can factor out 1 over 6 and write the inside as 2x plus 1. And this is important. You know why? Because when you write it like this, notice that the denominator is x squared plus x plus 1. The integration would be super easy because you can use u substitution, right? If this is u, then this is du. So you kind of get the answer right away, right? So from here, you basically get 1 over 6 times ln u, but ln u would be x squared plus x plus 1. I'm not adding any constants in this case because we're going to do that at the very end. Okay? Makes sense? So far, so good. Now, we were able to do one of the quadratics. Now, let's go ahead and do something similar for the second piece. We have the 1 over 6 again, but this time we could probably take out a negative 1 over 6. And this will be 2x minus 1. And remember, the denominator is x squared minus x plus 1 dx. Now, we can use the same strategy, call this u. This becomes du. You have to take out negative 1/6 and write this as ln of x squared minus x plus 1. Now, the reason why we don't need absolute values here and here is because those expressions are always greater than 0. And you can check that by looking at their discriminant. Okay? So, the whole thing, if you call that integral I, the expression, then you get something like negative ln absolute value of x plus 1 over 6 ln x minus 1 plus 1 over 6 ln x plus 1 plus 1 over 6 ln x squared plus x plus 1 minus 1 over 6 ln x squared minus x plus 1 plus c. Finally, at the end, we get our constant. And of course, you can kind of put it all together, right? You can kind of combine things here and make it a little, better looking, like negative ln absolute value of x. Obviously, these two things can be brought together. Basically, they all have 1/6, right? So we can kind of do this. Take out the 1/6 and then put an ln for the whole thing and forget about the absolute value. Write this like x minus 1, x plus 1, and then x squared plus x plus 1. And of course, we're going to have this in the denominator because its coefficient is negative, right? So that pretty much takes care of the whole thing. And then from here, you can definitely come up with something else. So let me go ahead and show you. These two will give us x squared minus 1. And then if you kind of put it all together, you can kind of arrive at something a little nicer. Because if you think about how we factored this expression, we had x minus 1, x plus 1, right? And then x squared plus x plus 1, and then x squared minus x plus 1. Make sense? So you can basically kind of put it all together and simplify that and write it in the simplest form. I'm going to leave that for you to do because we are going to talk about the second method, which is supposed to be more elegant, right? Are you ready? Okay, let's go. And decide which, let me know which one you like better. So we have an integral again. Let's just, write it as dx over x to the 7th minus x. That's our integral. And now I'm going to go ahead and factor out the x again, same way. But this time, I'll be using a different method, like very, very different method. And this is going to be pretty elegant, I got to tell you. Okay? So my substitution is going to look like this. I'm going to set u equal to x squared. And you'll see in a little bit why this is super helpful. Of course, from here, du becomes 2x dx. And we don't have that in our expression, right? But that's okay. Now, here's what we get from here. Obviously, you can isolate dx and write it as du over 2x, since we don't have that particular expression. And then kind of replace everything with what it is. Let's replace dx with du over 2x. And everything else will kind of hopefully fall into place. We're going to replace, just x is going to stay the same, right? And x to the 6th power minus 1, since this can be written as x squared to the 3rd minus 1. And since we call this u, it's going to be written as u cubed minus 1. Go ahead and, turn this upside down and multiply. That's going to give us du divided by 2x squared multiplied by u cubed minus 1. And notice that x squared is equal to u, so we can now replace this with u. That's going to give us du divided by 2u, and if that's your birthday, happy birthday to you. All right, so we get the following expression. Now, this expression, even though it looks complicated and it looks like you're going to need to do the partial fractions again, that's not the case. Let me go ahead and show you the trick. First of all, let me pull out the 1/2 so that we can end up with something like this, 1 over u times u cubed minus 1 multiplied by du. This is where the trick starts. So I'm going to go ahead and take this expression, and I'll do a little bit of hocus pocus on it, okay? Ready? Now, we're going to go ahead and write the numerator as u cubed minus 1 plus 1. My idea is basically the following. Instead of 1, I want to put something that contains this so that I can split it up, okay? Now, we can kind of write it like this. And then, of course, we're going to go ahead and split it up like this, right? Which kind of makes sense, doesn't it? And that's going to give us u cubed. Let me see if I left out anything. U cubed minus, no, okay, u cubed minus, okay, that's not right. That gives us u cubed. Okay, I meant to write u cubed minus u cubed plus 1. Exactly, that's what I need. And then that's divided by u times u cubed minus 1. And now we can go ahead and split it up into 2 pieces, and it's going to look like this, okay? One of the pieces. And obviously u cubed and u will simplify. So you'll end up with u squared divided by u cubed minus 1, and then minus 1, right? Of course, there's going to be a u here, so it's going to be minus 1 over u. Here we go. Now, this is the expression I want to integrate. And actually, integrating this is fairly easy. Why? Because of the u sub here. But this is not going to be a u. Maybe you'll use a t, right? Let's use t. If that's t, then this is dt, or 1/3 of dt. So basically, you're going to be getting something like 1/2 on the outside. Of course, let's not forget that. And then inside, we have 1/3 of ln u cubed minus 1, which is this expression right here. And then, and then it's going to turn into minus, this is just going to be ln u, right? And again, with the absolute value. And of course, at the end, you're going to have a constant now. If you go ahead and, substitute u equals x squared, that's what we had, right? You're going to get, and distribute everything, you're going to get something like, for our integral, 1/6 of ln x to the 6 minus 1 minus ln absolute value of x plus c. And I'd like you to compare this to the result we got with the first method. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath, the Shorts channel, and aplusbi. And bye-bye.